Good afternoon, everyone. My name is Giorgia Marcellino, and I'm a PhD student from University of Padua. Today, I'd like... sorry. Can you hear me now? Okay. I'm Giorgia Marcellino, a PhD student from University of Padua, and today I'd like to share with you my research titled Relational Databases in Digital Platforms for Monitoring Verona Arena Case Study. Cultural heritage monitoring is a complex process which involves a variety of stakeholders and different tools. This process generates a lot of data coming from the monitoring system, the simulations, and all the information around a structure. With the adoption of new technologies such as IoT, FEM, and BIM, this amount of data has highly increased, and most of all, they are from different formats. For this reason, to leverage all of this data, it is important to find a way in order to integrate all of them in the most as possible interoperable and heterogeneous way. Literature have demonstrated how the BIM environment can be integrated with the sensor data coming from a monitoring system, but most of the articles that we found focused on integration within proprietary BIM softwares. For this reason, our research focused on open formats such as the IFC standard. But we found inside the standard the class of the sensor that can get the properties from the monitoring system, but the standard shows limitation when handling time series data that are the kind of data that we get from our system. So literature suggested in the integration between IFC with the relational databases, which are the most appropriate for handling dynamic data. Our aim was to efficiently integrate and visualize IoT data in real time within a BIM model while maintaining open protocols. We developed a methodology that we applied to the case study of the Verona Arena, which is in Verona, Italy, and is currently monitored by the municipality. In the paper, we proposed a framework that is made up of 4 different phases. The first one is database analysis, in which we analyze the database starting from the sensor database, which is a relational one, and the IFC model that is converted into an SQL database too. Then, in the second phase, we integrate the sensor database into the IFC, and the updated database is then converted back into the step format into the third phase, and then is visualized in an online platform. This process has been automated through the use of a batch file that is triggered whenever the SQL database of the sensor has new data. So now let's go more in deep into our methodology. As I said before, the first phase is the database analysis, and in this phase we described the 2 databases that we had. The sensor database is made up of 4 different tables, one for the identification of the typology of the sensors, the second is a list of all the sensors that are actually in the structure. Then the third one is for the definition of the parameters that are acquired in the monitoring system. And finally, the last table, which is the sensor data, is for the collection of the values that are measured in the structure, and is the one that is updated every time that the monitoring system gets new values. On the other hand, we have the IFC database, which is a database that is created through the use of a GitHub script made by Bock and Heather. And it starts from an IFC file containing all the characteristic elements of the arena and also of the monitoring system. This database is called ifcSQL and is designed for storing IFC files with all the classes and the properties and relation of the data of the schema. In the second phase, which is the actual core of our research, we integrated the 2 databases together. We created 2 different scripts. One is called map table creation and creates a table which gets all the information about the monitoring system from the ifcSQL database. As you can see in the slide, in this table you can see all the information of the sensor that we have in the structure, and it's created at the beginning of our process, and at the beginning it has just fictitious values. These values are then updated with the second script called database update, which creates at the beginning a fictitious table called sensor table, which gets the last value from the sensor database according to the last assessment date. Then from the sensor table we update our map table, and finally from map table we update the ifcSQL database. In the third phase, the updated database of the IFC is converted back into the step format using another script made by Bock and other. And finally, this final file is visualized in an online platform that we have created and is online. The link is online with our in the paper. As you can see, you can move into the model, select the elements, and see the new updated properties. To sum up, we managed to update an IFC model using information coming from a monitoring system using the IFC standard. But we want to highlight that we didn't want to update the model with all the information coming from the monitoring system, since, as I said before, from literature we saw that the IFC standard isn't the best solution to handle time series data. So we have two different databases. One is the IFC one, and is very fast and light because it has only the last value coming from the monitoring system, because its purpose is to visualize and locating the data. On the other side, we have the SQL database coming from the monitoring system that is the most appropriate solution when querying and analyzing data. Other findings are that we provided an automated mechanism for data mapping and conversion between different database formats, and that our framework allows for the integration of any type of information into the IFC model, starting from a relational database. So we use the information coming from the sensor data, but we want to try to add also other kind of information. And it is important to highlight that we face some challenges because we started from two different relational databases that were a MySQL for the monitoring system because it was already created, and on the other side we had a Microsoft Server database because the script worked only in that databases. So we faced some problems when connecting and integrated the two, and we wanted to try to study more about this topic. Finally, future works will regard the integration of other databases and other information, such as the degradation. We are working on a digital twin for the FEM analysis, starting from data coming from the dynamic sensor, that we sent the data to a FEM model of the arena. And finally, we will try to work on our framework related also to other domains, such as the energy management of the buildings. Thank you for your attention.